Welcome back. In this session we will discuss about data models. So first let's see what is meant by a data model. Data model is a collection of concepts used to describe the structure of a database. So we need some concept to describe the structure of a database, and that concept or that collection of concepts is called a data model. So first we need to explain what is meant by the structure of a database. The structure of a database includes what are the data types of data elements inside the database. For example, we have already seen the university database, in which there are 3 files. In the previously discussed example, there were 3 files. First one was student, second one was course, and third one was section. And each of these files have different data items. For example, student has student number, name, and program, and each of them has a data type. So structure of a database should include the data types of different data items. Apart from data type, there should be some relationship between these 2 files. That is also already explained, because we have already seen that the course should belong to some particular department. So the course file is related to department, section is related to course, and so on. So there should be some relationship between all of these files. And finally, there are some constraints on the data that can be entered into the database. For example, the name can contain only strings. Student number should be unique. That means student number should not be repeated. So these are the terms that you should consider when you talk about structure of a database. And this data model provides necessary means to achieve data abstraction. Why do we need to describe the structure of a database? Because it provides means to achieve data abstraction. So what is meant by data abstraction? Data abstraction is the suppression of details of data organization and storage. We need to hide the details of how the data is stored inside the hard disk. Because as a user, I don't want to get complete details of how data is stored in the storage. But I want to get the details of essential features of data, and that is what is all mentioned here. Suppression of details of data organization and storage, but the highlighting of essential features for an improved understanding of data. If we think about how the data is stored, we may not get the complete understanding of what is the data. So those details should be hidden from us, and the details which are essentially needed for us will be only presented to us. So that is called data abstraction. So this is a data model. There are different types of data models, and they can be categorized into 3. The first one of them is high level or conceptual data models. So what is meant by that? High level or conceptual data models provides concepts that are very close to the way many users perceive data. So this model, data model, is very high level. In that sense, this model will not get into the details of database management system, or it won't get much information about how the data is stored and all. It will be just very high level. We will see one example for high level data model, but basically it provides concepts that are very close to the way many users perceive data. So the next category of data model is low level or physical data models. This data model provides concepts that describe the details of how data is stored on the computer storage media. So this is somewhat in detail. Lower level means we are getting deep into the model. So they provide concepts that describe the details of how data is stored on the computer storage media. And these are generally, this physical data models are generally meant for computer specialists. Okay? Normal people or naive users will not get an idea about physical storage or physical data model. And in between these two models, there is another model called representational or implementational data model. And this data model is somewhere in between the other two, that is high level and low level data model. So they provide concepts that may be easily understood by the end users, but that are not too far away from the way the data is organized on the computer storage. So it is easy to understand, but not too far away from the in-depth detail of how data is organized in the storage media. So we will be learning about a representational model or implementational model in the rest of this module, and that model is called a relational data model. All the other models are not discussed in this course, but for understanding purpose I am saying that there are three categories: high level, low level and representational. And out of this we will concentrate only on representational model. There are many representation models, but we will concentrate only on one of them, and that is relational data model. This representational data model hides many details of data storage on the disk, but they are easy to understand also. So these are the different categories of data models. So before getting into the representational model and relational data model, we will get a brief understanding of one of the high level data models, and that model, high level or conceptual data model, is called ER model or entity relationship model. So this model will be explained with the help of three terms, and those three terms are entity, relationship and attributes. So what is meant by entity, what is meant by attribute, and what is meant by relationship. Okay, so this model is called the ER model. So let's explain this with the help of an example. To get a brief understanding about the model, we will explain one example. Let's say that we are storing a database about an organization or a company. Okay, so the database inside the company will have details about the employee. So employee is an example for entity, and each employee will have different attributes. For example, employee entity will have employee number, employee name and department to which that employee belongs. For example, employee may be belonging to a finance department, he may belong to an HR department, he may belong to a marketing department, and so on. There may be other attributes also, but in this example I have only used 3. So this is one entity, and the features of entities are described using attributes. So this is an example for attribute, this is an example for attribute, and this is an example for attribute. Let's take one more entity, and that entity is called a project. That company may be doing many projects. Okay, so say for example this company is about a building construction company. Okay, there will be many employees working on that, and they may have many projects at different locations in Kerala. So the project entity has 3 attributes, and that is project number, project name and location. There may be others also, but we will mention only these 3 attributes. So these are the attributes of this entity. So what is an entity? Entity is any real world object. Okay, it may be an employee, it may be a project, it may be a student, it may be a customer, and so on. Each of the entities will be described with the help of some attributes. And we need one more term here, and that is called relationship. So now we have 2 entities, but they should be related in some way, and that is called a relationship. In this example, an employee works on project. Each employee will be working on some project of the company. So this is represented like this: employee works on project. So this way of representing data is called a high level or conceptual data model, and this particular example is called an ER model or entity relationship model. We can think of this as suppose you are building a new home for yourself. Okay, so before building the home, you need a plan, right? The architectural or engineering team will provide you with a plan. That plan is done well before starting the work. Why? Because we will get an idea about how the rooms will be organized, what will be the size of each room, what are the facilities in the home, and so on. But it is not the actual work, right? Similarly, before building a database, we should have an understanding of what are the data to be stored in the database, how they should be connected, and many other stuff. So if you have a good plan before building an actual database, your database will be a good one. So conceptual model is used only for that purpose. It is not used for any implementation purpose. Okay, so this is something like a plan of your building. Okay, so a plan of the database can be considered as a conceptual model. So this way of representing data is called ER model or entity relationship model. We will not talk about physical model because it is very detailed one. We will skip that. We won't mention anything about the physical model. But the next model, representational or implementation model, will be discussed in detail in the rest of the course. But before getting into that, we should be knowing some of the other terms used in the data model. Okay, we will give a brief introduction about one of the representational model, and that model is called relational model that I have already mentioned. We will see that in detail. This is the most frequently used model in traditional database management system. There are other representational models like network model and hierarchical model. We won't get into the details of these two models also. Representational data model represents data using record structure and hence are sometimes called record based model. For example, we have already seen students' details are stored as rows and columns, and this is called record structure. So these models are also called record based model. Okay, so we will see this in detail at a later point of time. Next, we will see some of the terms used when discussing about data models, and the first term is database schema. So what is meant by database schema? Database schema means structure or description of a database is called a schema, and it is specified during the design of the database, and it is not expected to change frequently. It is like your building plan, so it is specified during the construction or the initial stages of the construction, and it is not expected to change, right? Once you made the plan, you should construct according to that plan. Similarly, the structure of the database is defined or specified during the design time, and it is not expected to change frequently. There may be some changes occasionally, but that is okay, but it is not supposed to change frequently. So this is called a schema. So let's see an example. So this is an example for database schema. It just specifies a structure only. No data is mentioned here. So from this diagram we can see that this database has three tables or three files: section, department and course, and each of them has different number of columns. For example, section has section ID, course code, SEM, year. Department has department name, building and budget. Course has course code, course name, credits and department. So this is called a schema diagram. Okay. So database schema means structure of the database, no data. And the next term is database instance. Data in the database at a particular point of time is called database instance. It is also known as database state or snapshot. It changes each time a new record is added, or an existing record is updated, or an existing record is deleted. Okay, so let's see an example. So this is not a schema because it has data in it. At this particular point of time, this has 4 records in it, and this is the snapshot or this is the database instance at this moment. Suppose I am adding a new record at the end, CS03 database management system and something else. Then the database instance changes. Okay, or if I delete any of these things, then also database instance changes. If I update something, then also database instance changes. So at a particular moment, what is the data inside the database is called database instance. It will change frequently. Okay, it is not like schema. Schema is just the structure part. Okay, when a new database is defined, the corresponding database is empty. So first time when you create a database, you will create only structures. There won't be any data in it. Then the database is in an empty state. Okay, when you add data, the current state will change, and every time you add, update or delete something in the database, the state of the database will change. Okay, so these two terms should be in mind: database schema and database instance. Okay, so with this we will conclude this session and we will continue in the next session. Thank you.